how to draw the isometric view of simple shapes. So we will take the same example, a square of say side 50 millimeters. A square in isometric view, how it will look in the front view, how it will look in the top view, that we will see. So this is a square of side 50, ABCD. Now this is the orthographic projection of this square. Now how will this square look like in a isometric view? So as I told you, isometric view, the vertical line remains vertical and the horizontal lines are inclined at 30 degrees to the ground. So now I will draw a line inclined at 30 degrees which will be equal to the length of the side of this square. Right? So the square is like the, the square plane is like this, and when I look at it at an angle, so it will get tilted like this. So when it gets tilted, this remains same, this vertical line or this edge remains same, and whereas when I tilt it like this becomes a rhombus. So this vertical line, as I told you earlier, the vertical lines always remain vertical, right? So this vertical line I have drawn, this horizontal, this becomes inclined at 30 degrees because I am tilting it, or you are tilting the angle. Now again, as I told you, this is a isometric line because it is inclined at 30 degrees. So at the top edge of the square will be parallel to this because isometric lines are all parallel to each other. So from this point, so now this is A and this is B and this is your D, and from D draw a line which will be parallel to this and equal to the length of this. So this is the isometric view of the square plane. But then there is one more possibility. I can keep it like this, keep this fixed and tilt it like this, or keep this edge fixed and tilt this edge. So both are possible. So in the second case, what will happen? Right? So I kept this vertical edge fixed and I tilted this side. So and now I have this, so this will be my C. And these are two possibilities depending upon which edge I am fixing it and which edge I am rotating it. So this is the front view of the square in two possible orientation, this way or this way. The next is the top view of this. So obviously the top view of this will be a rhombus because when I tilt it like this, it will become a rhombus. So how do we draw a rhombus? So draw two lines 30 degrees inclined with respect to the horizontal. So suppose you take this as A, right? And then, so it will be like this. So this is my corner A and this is B and this is D and I need to draw C. So how will I get this corner C? So as I told you, these are all parallel lines or isometric lines. So from D, draw a line which will be parallel to AB. And then, so this will be my C. Connect C with B. So now you can see CD and AB are parallel to each other. AD and BC are parallel to each other. This is what we discussed earlier. Isometric lines will be always parallel to one another. Right? So this is about a square where you have the edges all parallel to each other. So earlier we saw how to draw the isometric view of the square. Now we will see how to draw the isometric view of a rectangular plate. So you have a rectangular plate of ABCD and this is the rectangle. So it's almost similar to that in the front view of your rectangle, how to draw that. So again there are two possibilities. I can hold this edge and then tilt it, or hold this and then tilt it. So two possibilities are there. But again remember this vertical line, this edge remains vertical. So I have drawn the vertical edge BC and now I am tilting it towards this side, means I will draw a line inclined at 30 degrees. And length equal to the length of the side AB. So once I have drawn this, then this AD will be parallel to your BC, because again they are isometric line. So from here draw a vertical line, because this is a vertical line. This again I am repeating, this vertical line CB and DA will be again a vertical line in your isometric view also. So draw a vertical line of length equal to the DA here and then join these two. So this is the isometric view or isometric front view of this rectangular plate. And similarly the other option is right. So instead of a CB, I have fixed AD here. This is AD and I have tilted this, so it goes towards this. And now what will be the top view of the rectangle? Again in top view also there are two possibilities. Length can be this side or this side. Whereas in case of a square you had only one option, in case of a rectangle two possibilities are there. So what I will do, I will draw two lines inclined at 30 degrees with the horizontal, which will represent AB and AD. And once you have drawn this, from D you will draw a line DC which will be parallel to AB and then connect CB. This is one possible orientation. So this is another possible orientation, because length is towards your right, whereas here length is towards your left. So depending upon which way you are going to orient it. So this is how to draw isometric view of a rectangular plate. Now whatever we saw, both in case of a square and also in case of a rectangle, you had lines like this, or in other words, all the lines were isometric lines. So now we will draw the isometric view of a triangle. We have a triangle now. It's a triangle. So there is one line here. When you keep it like this, these two are inclined lines, means they are not parallel to the isometric lines. So this is what earlier I told, these are called non-isometric lines. So for example, what will you do if I ask you to draw the isometric view of this triangle? As usual, you will draw a horizontal line which will represent AB here, and this will be inclined at. So this will be able to do it. But the next question is, how will you complete this triangle, or how will you find out this point C? So I don't have any other reference because they are not isometric line, they are non-isometric line. So whenever you have an object where you have non-isometric line, you cannot directly get the isometric view of it. So then how do I go about it? Whereas for when it is a rectangle or a square, I have the method to draw the isometric view. So what we will do, we will enclose this triangle. So we will enclose this triangle, we will enclose this, triangle inside a box. So the box could be a square or a rectangle depending upon the size and shape of this. So once I have enclosed it within a box, I know how to draw the isometric view of the box. So instead of directly trying to draw the isometric view of the triangle, first we will draw the isometric view of this box 1, 2, 3, 4. Then we will see how to draw the isometric view of it. So this we very much know how to draw the isometric view of this box. So having drawn this box, now we have this A, B, C corners. These corners we will try to draw it over there. So probably here you have this corner already, you have A, and this corner B you already have here. So this is my AB. Because it's again an isometric line, straight away I drew it. Now we have to locate C on this. So to locate C, what you have to do is measure this distance 1C. Of course, if it is an equilateral triangle, 1C and C4 will be same. If it is not an equilateral triangle, it will be different. So measure 1C distance and transfer that here. So remember, this is an equilateral triangle, so you can measure from here or here, both will be same. Otherwise, if you are measuring from end 1 to C, measure from 1 to C. Instead, if you are measuring from 4 to C, you have to ensure that you are measuring from 4 to C. Right? Now having located the C, all that I need to do is connect C with A and B. So now I got the isometric view of the rectangle. The triangle. You may ask me a question, sir, what will be this angle? Do I know the angle? I need not bother about those angles because for non-isometric lines you have to do only this way. Enclose it within a box, draw the isometric view of the box first and mark all the corners on that and connect them using straight line. Then you will get the isometric view of the triangle. So the same method you have to adapt for other planes like if it's a pentagon or hexagon where you have inclined lines, means they are all non-isometric lines. So you have to enclose it within a box and then draw the isometric view of it. So let's take a pentagon and see how to draw the isometric view of the pentagon. So as I told you, there are non-isometric lines. Once there are non-isometric lines, you enclose it within a box. And once you enclose it, then draw the isometric view of the box, and then you take these measurements and transfer it. Say for example, you have, we'll start with A, this is 1A, measure 1A and mark it here. And similarly 1B. And of course it's a regular pentagon, so 1B and C2 both will be same. So what you can do is take a divider, measure this distance, mark a point here, mark a point here. And similarly, this 1A and 2D, the height will be same. You need not measure it twice. First, when you measure itself using a divider, straight away you can mark it here. This will be your D. And then finally your E. This is 4E. So now you have marked all the 5 corners of the pentagon. Now join them. So this is the isometric view of the pentagon. And here also what we have drawn is the top view. Once you say top view, they will be inclined at 30 degrees each. Now what if you want to draw the front view of this pentagon? So similarly what we did for the front view of a square or a rectangle. Right? So again the one edge is vertical here, this is 90 degrees and the other one is inclined at 30 degrees. Now we have drawn the front view of the box. So in this we will mark the 5 corners of the pentagon. So again here measure 1B, mark here, and also you can measure from the other side, because as I told you it's a regular pentagon, both the sides will be same, it's symmetrical. So this will be your, and then measure 1A and mark it here and this, because both will be same. So this is your A and this is your D, and measure 4E, mark it here. Now connect them. So this is the front view of the pentagon. And again there is another possibility, as we saw in case of a square or a rectangle, 2 possibilities are there. So this is how you need to draw the isometric view of objects which have non-isometric lines. So of course once you know this, the same method you have to adapt for drawing the isometric view of a hexagon.